Hello everyone, welcome to this tutorial on transient stability analysis. As you know, transient stability analysis is performed in a system to investigate the response of the system frequency or the generators after a disturbance has taken place or a contingency has taken place. In this experiment, we will use the data from the load flow that we did on the previous tutorial and use the solution of that load flow to do transient stability analysis in this experiment. So let's dive in. Let's open PSAF. The version of CYME PSAF we are using is 2.81 revision 2.9. So first thing first, we need to specify the check if the database and network paths are on the same folder that we have our study stu file and the .sol file from the previous experiment. In my case, this is in the F drive and the tutorial folder. As you can see, all the database and network paths are correct, so I am good to go. After that, you can open the study using tabular format. You can open the previous study that we did on the previous tutorial, that is the loadflow.stu. You can either click the last network associated, or you can manually choose the network by selecting the .nwt file from the previous experiment. As you can see, the bus data are derived from the previous experiment. Let me derive all the data: the fixed step transformer, the generator, the line data, and finally the static load data. All these data were entered and simulated in the previous experiment for the load flow study. If you have if you didn't save the solution of the load flow in .sol format, let me do that for you once again. First of all, we select the power flow analysis solver and you go to study, click on select. Based on your system, you can this can either read 23 components or 0 components. In my case, it's 0 components. All my components are already selected. And finally, go to solve, select Newton-Raphson, select these options, and make sure to keep this option checked: create input file for same step, and then click solve. And now PSAF prompts you to save the solved case. You can either replace it or save it as a new name. I'm gonna replace it. I'm going to click it and I'm asking it to replace it, yes, and then we have successfully saved the SOL file, the load flow file, in our folder. Now let us go for the transient stability analysis. For that, we first select a solver from the analysis menu. In this case, we select the transient stability analysis menu from the engine selection dialog box. We select it, then we go to study. We have many settings for in this dialog box. First, we go to the settings tab. We first specify the system frequency. In my case, this is 50 Hz. In your case, it can be 60 Hz or 50 Hz. The base power in MVA is 100 in most of the power system cases, so let's leave it to that. And finally, go to settings tab. And finally, we need to specify the amount of time we need to simulate our model. We want to see the response. Let's put it to 50 seconds and see how the cycle is calculated automatically by the software. We then go to the LF data tab. This is the data. This is the tab where we specify the load flow data from the previous experiment. We click on browse and tell PSAF which is the SOL file for the system, the load flow file. We select the SOL file we created earlier. We then go to the global load tab. In this tab, we specify the type of load we are modeling in our power system. As you know, there are 3 types of load in a power system: constant impedance, constant current, and constant voltage load. We will be using constant voltage load in our system. Constant impedance load in our system. So we'll specify NP2 and NQ2, and we are leaving 0 for both P frequency and Q frequency components. By this, we are saying that we will not consider load frequency dependent loads like induction motors in our power system. Then we go to the global selection tab. In this tab you can select either the generators will have their governor response or governor set points activated. In this case we will exclude the controls. Then we will go to the events tab. See, the transient stability analysis is performed mainly when disturbances occur in a power system. So we need to manually disturb one or more components in our system. Let's say we want to apply a bus fault. For that we go to the events tab, click on edit, click on add and apply bus fault right here. Okay. So we have a couple of options. First we need to select, we need to specify on which cycle do we want to apply the fault. Let us select cycle 5. On the 5th cycle, the PSAF software will apply a bus fault on bus 7 perhaps, and if you uncheck none, you can specify the time or the cycle when it will be removed. Let us specify cycle 10 when it will be removed. So the bus fault will be applied for 5 to 6 cycles or 0.1 second. We want our fault type to be triple L or 3-phase fault. Let's click on apply and see PSAF is applying a bus fault at 5th cycle on the bus 7 and is removing it at cycle 10. So we can click on OK. And finally on the monitoring tab we need to specify which quantities we do want to measure. Suppose we want to measure the bus frequency, so we can select all the bus frequencies like that. We can press on control and click on the left mouse button to select all these components and click on add, so you can see all the bus components are added. And also generally we need to see, we want to check the generator response, how the angles are changing, how their frequencies are changing. We can select all these and also add them, so the generators are selected for monitoring the response. We can click on OK and all the parameters are selected, and now we are ready for transient system analysis. Then under the analysis tab again we click on solve. Now we can put a title for a subtitle for our study. Let's put transient analysis tutorial. Click on solve, the green icon, and you can see PSAF is performing simulation for the transient stability analysis for 50 seconds as we specified, and it has successfully completed the analysis. You can click on OK and it will open chart selector. From this you can actually plot any generator or any bus and see their responses. Which responses can you see? For the generator, let's see generator 1. For time axis you can select x axis, you can select time, and for y axis you can select either the angle or the speed, which is in essence the frequency of the generator, because you know speed is directly proportional to the frequency, or the voltage, active and reactive power of the generator. Let's see, we want to measure the speed or in essence the frequency of the generator. We can click on plot and voila, the plot is here. Don't close it just yet. We can plot the frequency of the buses. You can actually plot multiple things at once. You can press on control key of your keyboard and select multiple attributes, and for bus we want to measure the frequency response at that bus. We can select plot and all the frequency response are plotted in of all the buses in a single figure. So let's click done, OK, and these are the figures. As you can see, we can select we can see the value of each frequency at any given time, but it would be better if you could get all the data points in a table. So let's do that. Let's close these windows. Yeah, you can uncheck, you can click on this sheet and then go to report and start CYME view. Report, start CYME view. If you click on that, see that we have a folder named model grid, and under that we have a folder named transient analysis tutorial that we created. This is the simulation that we created just now. If you double click on this file, it shows the same interface that we saw earlier. If you want to see the angular output or the speed output, or the frequency output from these 3 generators. You can select these 3, click on speed for the y axis and plot. Voila, the plot is here. But interesting fact is you can now see all the data points of this curve for all generated 1, 3 and 5 underneath the plot, and you can actually export these plots to a Microsoft Excel file maybe. For that you can click on this box right here, right click on it on your mouse, and then click export. But you can directly export it to Microsoft Excel, but for me it doesn't work. So instead I click on Internet Explorer. So let's see how that looks like. Okay. So the speed plot for all the generators are here in Internet Explorer. I can press Ctrl A on my keyboard, copy all of it, and press Ctrl C to copy it. I can then open Microsoft Excel. Sorry, it's taking a little bit of time. Okay, can create a blank workbook and paste it here, and there you go, all the data in Excel. You can do it for any plot. You can say you want to plot the frequency of bus 7. Okay, you have the plot right here, and you have the frequency components right here. You can export it just the same way I did before. So from Excel you can do further analysis. You can plot the speed of generator 3 with respect to generator 1 if the generator 1 is your slack bus, or anything like that. So this concludes our simulation, our experiment on transient system analysis, stability analysis, and hope you enjoyed it, and tune in for the next tutorial. Thank you.